Okay, for these three, you're going to need to know your derivative rules for the inverse trig functions. And you'll combine that inverse trig function derivative with some chain rule, because notice inside each of these trig functions we have a more complicated function. So if we look at part A, we're interested in taking the derivative of the tangent inverse. So that means we need to know the rule for tangent inverses. Well, the derivative of tangent inverses are 1 over 1 plus whatever's inside the tangent inverse squared times the derivative of the inside. So the derivative of that root is a 1/2 x to the negative 1/2. So if I finish this, I end up with a 1 on top. I'll have a 1 plus x, and then I'll have a 2 and another root of x on the bottom. So there's my answer. If we look at B, we're taking the derivative of the cosecant. So the cosecant is a little trickier. The cosecant is going to be a negative, because it starts with a c, 1 over the absolute value of the inside times the square root of the inside squared minus 1. So now if we simplify this, I've got to do the chain rule, excuse me, I've got to now multiply by the derivative of that inside. Well, that'll be a 1/2 times a 5x to the negative 1/2 times the derivative of the 5x now, which is a 5. So notice that I had to apply 3 rules. I had to do the cosecant inverse rule, I had to do the power rule, and then I had to do the derivative of the 5x. So here's the cosecant inverse rule applied, here's the root applied, and here's that 5x. So now my job is to simplify this. Notice that a radical, a principal square root, is already positive, so the absolute value is going to leave it alone. So if I fix this, on top I can see that I have a negative 1, a 1, and a 5. So I can put a 5 on top. Then on the bottom I have a root 5x and another root 5x. So if I multiply those together, I will get a 5x. And inside, I will have a 5x radical squared is a 5x minus a 1. And then the last thing that I have is this 2. So if I look now, these 2 5's can cancel, and I will end up with a negative 1 over a 2x times a root 5x minus 1. Part C works the same way as A and B. All 3 require you to remember your derivatives of inverse trig functions. So that's really the toughest part. And then we combine it with some chain rule. If we look here at part C, we notice that we're taking the derivative of an inverse cosine. And cosine starts with a c, so we know that the derivative of any trig function that starts with a c will be negative. So we need to remember the rule for cosine inverse. That's a negative 1 over the square root of 1 minus whatever was in here squared. Then we have to multiply by the derivative of what was inside the cosine inverse. So the first thing that we hit is the root. So derivatives of roots are 1/2 whatever's inside the root to a negative 1/2. And then lastly, we have to hit the x squared minus 1, whose derivative is 2x. Notice we applied 3 different derivative rules. We had the cosine inverse, we had the root, and then we had the polynomial inside. So here's the derivative of our cosine inverse, here's the derivative of our root, here's the derivative of our polynomial inside. So now in order to get the answer that I will give on a multiple choice test, we need to be able to simplify this. So the first thing I see here is that this 2 and this 2 will cancel, because one's on the bottom and one is on the top. So that means on the top I'll have a negative 1 times a 1 times an x. On the bottom I'm going to have this root along with this root, because the negative power will put that root on the bottom. Now before I finish, with this one and write it down, I want to talk about what happens when I square that square root. When you square square roots, all that occurs is you lose the parentheses and you lose the radicals. So really we're left with a 1 minus all of this inside. So I'll have a 1 minus an x squared plus a 1. So I'll end up with an x squared, a 2 minus an x squared, excuse me, and that'll all be inside this root. So that's the answer for our part C.